Momentum is conserved in an elastic collision, and we're breaking out some equations to help you see that. So momentum is directly proportional to mass. So as you get more mass, you have more momentum, okay? And it's also directly proportional to speed or velocity. So as you have more speed, also have more momentum. But you'll notice that every time the numbers here are conserved. So let's look at some examples. So here we've got a squirrel and a monkey that somehow weigh the same amount, but okay. And so the monkey's not moving, so all of that momentum from the squirrel is going to get transferred to the monkey. The reason it's telling us we're not quite getting it right is because they actually want to see if we can get the monkey to go 2.5 meters per second. So again, if the masses are the same, the only thing we can change is the speed. We know that the initial speed going in is going to match the speed going out. All right. Let's take a look at one more. So this time we've got Goldfish riding skateboards for some reason, but we can see that even though one is going faster than the other, again, see that momentum, it is conserved. Now it's saying try again because it wants to see if we can get the fish to go 4 meters per second after the collision. And again, if the masses are the same, then we have to have the same speeds going in if we want to have the same speeds going out. There you go. So check out these examples and more at phenomena.app.